We're going to continue on our Finding Real Roots lesson, going straight into some word problems, some application problems. The application problems are all volume, geometry type problems, so they're really not too difficult. You just have to know what you're reading. First one, the design of a box specifies that its length is 4 inches greater than its width. The height is 1 inch less than the width. The volume of the box is 12 cubic inches. What is the width of the box? Volume, it's always length times width times height. The problem says that length is 4 bigger than the width, and height is 1 less than the width. And the width is the width. So take that information and set up your multiplication. Length times height times width equals 12. I FOILed this. First, outer, inner, last. Simplified, collected like terms, and then I multiplied everything by W and subtracted 12 from both sides. I graphed this on my calculator. I found that it crosses the x-axis at 3 spots. I can also look in the table and see where y equals 0. What is the x value? -3, -2, and 2. Can we have negative widths? No. So our width for this problem is positive 2 inches. Excuse that typo. 2 inches, because it's the only positive root or 0 in the problem. Let's try one more. A shipping crate must hold 12 cubic feet. That's a volume, 12 cubic feet. The width should be 1 foot less than the length, and the height should be 4 feet greater than the length. What should the length be? Volume, length times width times height. The width is 1 less than the length. The height is 4 bigger than the length. So we set up our multiplication and come up with a polynomial. Width, height, length. FOIL these two first binomials, collect like terms, and then distribute your L and subtract 12 from both sides. Okay, graph on your calculator and you find that it crosses the x-axis at three spots. We can't have a negative length, so our length equals 2. Amazingly enough, the problem was just like the previous one, just with a different sort of label. All right, the next slide is quite wordy. I'm going to ask that you watch this part more than once to try to really understand the information. Write down the ideas and come tomorrow with questions. Not all polynomials are factorable with the information you've learned so far. They're not easily factorable. We can still find all of the rational roots. I've put in a note, sort of how when we did quadratic equations, that quadratic formula was the way that we could find the roots of anything, no matter what. So sort of how the quadratic formula helped us with quadratic equations. The first one is the rational root theorem. All possible roots of the polynomial are plus or minus p over plus or minus q. P is the factors of the constant. The constant is the last term in your polynomial, the thing without the variable. Q is the factors of the leading coefficient. The leading coefficient is the number in front of your biggest term. Polynomial equations may also have irrational roots. The irrational root theorem is if a polynomial has rational coefficients and a plus b squared c is a root, a and b are rational, c is irrational, then a minus b squared c is also a root. If you look, these two right here are conjugate pairs. Okay? Plus b squared of c minus b squared of c. So that means if we're going to get one, we're going to get the other. Like if we ever use the quadratic formula, that plus and minus in the middle means that we're going to get a positive and a negative, a sum and a difference. Not necessarily positive, negative, just a sum and a difference. Irrational roots come in conjugate pairs. Again, just to state it again with real numbers, if we know that 1 plus the square root is a root of, say, that polynomial, then you also know 1 minus the square root is a root. It's a conjugate pair. For example, a very basic first example, identify all the real roots of that polynomial. Leading coefficient, constant, p, q. P over q. So we do plus and minus 2 over plus and minus 2. We need to split that up and try to figure out how many numerators over denominator combinations we can get. So 2 over 1, 1 over 2, and 1 over 1. Those are all factors. Sorry, p over q. So p is 2. The factors of 2 are 2 times 1. So you can do different combinations. Factors of 2 are 2 times 1, so you can do different combinations. Those are just factors of p over q. Next, we're going to graph that. Graph it on your calculator and look for x-intercepts on the graph and or table. The graph looks sort of like this. So we have x-intercepts at about negative 0.45, about positive 0.5, and 4.45. That one right there is right there. It's part of our list. We're always going to look for an x-intercept that's part of our list. Okay, they're the same. So I'm going to use that, because I know it's part of my list, to do the synthetic division to check to see that it's a factor. If I use x equals 1/2 to check to see if it's a factor, and if I have a remainder of 0, remember, you know it's a factor with a remainder of 0. So 1/2, synthetic division. Okay, I got a remainder of 0, and unfortunately we're continued. So if you're still watching at this point, push pause, make sure you have everything here, because we're moving on to the next slide. From the previous slide, we just did the synthetic division, remainder of 0. So I'm rewriting the equation. X minus 1/2, which is right there, and I'm left with 2x squared minus 8x minus 4. I need to find the rest of the roots. A, C, and B doesn't work with this one, so I'm going to use my thing that always works, the quadratic formula. Okay, negative b plus or minus b squared minus 4ac over 2a. Okay, simplifies, apologize, we lost some letters there. So we know that x equals 1/2 and 2 plus or minus the square root of 6. Those are the 3 roots. And that first polynomial had 3 roots in it. It was x to the 3rd, so I know I need 3 roots as an answer. Another example, identify all the real roots. So I have p over q, plus or minus 4 over plus or minus 2. You do all of the factors of p over q. The factors of 4 are 4, 2, and 1. The factors of 2 are 2 and 1. So you're going to have all the combinations of p over q. Graph it on your calculator. It crosses at 0.5, and I found that using the table. This is the easiest way to find that. Negative 0.5, and then around negative 1.5, and around positive 3.1. Sorry, that's negative 1.1, positive 3.1. I don't know what those numbers are, because it wasn't in my table as a whole number, as a real number. Take this, do your synthetic division, and make sure you get a remainder of 0. Your synthetic division gave a remainder of 0, so I know I've got x plus 1/2, which is from right there, 2x squared minus 4x minus 8. That comes from right here. Okay, quadratic formula. Everything simples out to 1 plus or minus the square root of 5. So I know my roots are negative 1/2 and then 1 plus or minus the square root of 5. That's 3 roots, and I'm x to the 3rd. Okay, these are going to take some practice, but once you get it, you got it, and we'll move on from there. Good luck.